Okay, so let's start with question one, non-calculator. Maybe didn't start particularly easy. We are looking at the angle subtended from the same arc in part A, which is, this theorem that if you get starting at the same point, this angle is going to be the same as this angle. Now, if I turn this page around, there's our same points, and here's that shape. So A is going to be the same as 25. So you look at A to be 25. For B, I think we got a cyclic quadrilateral here. So look for the four corners to be on the circle. If they are of a four-sided shape, it's a cyclic quadrilateral, which means opposite angles add to 180 degrees. So 80 here and B add to 180, which means B must be 100. Which quadrilateral has two pairs of parallel sides, all sides the same length and no right angle? So all sides the same length is probably the key here. It's kind of like a square, but it's not a square because there's no right angles. It's pushed out of shape. It is a rhombus. What's a rhombus? It's a square pushed out of shape. A parallelogram is a rectangle pushed out of shape. No. Close enough with the spelling. Okay, so question 3 then is one of our known angles. So this comes from this thing, sine, cos, tan. And this comes up later again in the practice test. Set it up 30, 45, 60. There's a number of ways you could do it. 1, 2, 3 is what I think, a half. 1 over root 2 and root 3 over 2. And then it's the opposite for cos, root 3 over 2. 1 over root 2 and a half. You kind of need to know that. Not kind of, you need to know that. It's not going to be given in the formulas, so that's what you got to know. Only work out tan if you need it. It's just 1 over root 3, just the numerator or the numerator, and so on. For this, I just need cos root 3 over 2, so I go to where cos is root 3 over 2, and it is the degrees of 30 degrees. You need to be able to do that without the calculator. For the actual exam, I will set aside time you can use the calculator and not use the calculator. So part 1, calculators won't be touched, and then on to part 2, calculators are allowed, max. Sorry? It's just that you're just going to be split in 2 papers, so you're just going to have to finish with the first paper after 20 minutes and work the next 20 minutes or whatever it is with the second paper. So it's just going to be split in 2, because it has to be. Otherwise, you just use the calculator to get these things. Yeah.
Can we not use the calculator in the calculator section? Like, do we have to use it for all exercise?
Do you have to use the calculator? No. You don't have to use the calculator.
But, sir,
yeah.
For that one?
Yeah.
Like, all we have to know is that, like, remember that the chart? Yeah. Like, the 0, like, x is greater than 0 or something. What is that?
Oh, okay. So this just says cos would be root 3 over 2 in a number of places. Yeah. I'll upload this video, Max. You don't need to. But you can if you want. It just says, as you go around the unit circle, which we did, cos would be root 3 over 2 in a number of places.
Oh, okay.
So it's same between 0 and 90. Okay. All right, next question. This is difficult. I'm not sure how you guys worked it out or tried to work it out. First thing you notice is tangent here. So if I see this tangent, I'm looking for a 90-degree angle here. If I see that 90-degree angle, that means I have this triangle kind of. So the question is asking for y in terms of x. In other words, the answer needs to be something like 180 plus 2x, y is equal to, something like that. That's an example of what the answer might be like. You're not going to get y full answer as degrees. You're going to have x in it. Okay. There's multiple ways of thinking here. I went to here next to find this angle. What is that angle? Well, that's 90. That's x. And the whole thing has to add to 180. So it's 180, take away 90, take away x, which is going to be 90 minus x, this angle here, 90 minus x, which makes sense because that's 90. There's only 90 left. Okay, so that's 90 minus x. Okay, what's this one then? So I'm getting closer and closer to y. That's 90 minus x. Does anyone figure out what that one is? Taryn? Yeah, it's going to be 90 plus x. You could go the long way about that and say, right, these two have to add to 180. So in other words, 180 minus 90 minus x is going to be this one. So take away from 180, you get what's left. So that's 180 minus 90 plus x, minus x. That's 90 plus x, this one. Okay. Now I notice that there's an isosceles triangle here because two radius. Those two are the same, which means that these two angles are the same. Jane? This exact question? No, but one of similar difficulty could be. This is difficult. There's no doubt about it. This was a difficult question. All right, so I can get an expression for this in terms of y. So now I'm kind of looking at this triangle and I'm saying, I'm going to have x's and y's in this triangle because I know that this is y. Then this angle here is 180 minus y. And this angle up here is the same. I know it's kind of getting a bit complicated. But I have a triangle now with all angles known. And I know that when I add up angles that they must equal 180 degrees in a triangle. So let's do that. 180 degrees is this plus this plus this. 180 minus y plus 180 minus y plus 90 plus x. So I get 180 is equal to, I think we get 180 plus 180 plus 90, that's 360 plus 90. What's 360 plus 90? 450? 450. There's minus 2 y's and a plus x. Yeah. Thanks. Okay, so I just added 180, 180. All right, I want y equals. So I'm just going to try and, this is an algebra problem now, get y equals. I'm going to bring the y over here, or add it to both sides, just to make it positive and make it easier. Nola? Here? That's not, that was my example of what the answer might look like. Don't ignore that, because that was just that. That was before you came in. All right, so bring everything else over here. I got 450, take away this 180 plus x. 450, take away 180. 270. So I get 2 y's are equal to 270 plus x. Well, I only want what one y is, so I divide both sides by 2, and I get y is equal to 270 plus x divided by 2. Very difficult question. I think that was probably the hardest one in the exam. Yes?
I got the same answer, but I did it a different way.
Yeah. There's multiple ways of getting there because there's lots of similar angles, and that's just the way I used. There may be a quicker way. Yes, Taryn.
I got 135 plus x over 2.
That's the same. Yeah, the same answer. Just he divided 270 by 2 to get 135, and then wrote the x over 2. Okay. Maybe it'd be a good idea to try. Can you do this one again yourself tonight or tomorrow during class, and see can you redo what we did? Quadrilateral has exactly one pair of parallel sides. Write down the mathematical name. So it's a quadrilateral with one pair parallel sides, not necessarily the same length, and the other two are not parallel. That's a trapezium or trapezoid. Trapezium is the English name for it, and trapezoid is the American name for it, if you're wondering why there's two different names.
A trapezium can also have the two sides parallel to each other.
These two on this side?
Yeah.
No, that's a parallelogram then.
Oh, so the
Or a
other-
rectangle. All right, this one then, okay, straight line, 180, they all add up to, take them away, and I think you get 63. If you need me to do that slower, just give me a nod. No. Okay. All right. I think this was harder than a 1 mark, but it's a 1 mark because it's a theorem, and you're supposed to know. You're looking for DCB, so this angle in here. Anyone get an answer here they'd like to share? Hisham? 65. Taran? 65, yeah. Maybe Hisham, you can explain how you got it.
So we had one theorem where like if I think it was the theorem where like if there's 2 points and they come to the center or neighborhood, then if like there's an angle on the same side, we're on the edges of the circle, then it's half of that first angle.
Oh yeah. So you're talking about this theorem, the center of the circle, and you're looking for things that start at the same 2 points. This angle is going to be double this angle.
Yeah.
I think we can find one of those if you look hard enough here. Where did you find? You found it using this.
Yeah.
So DCB and DOB. Yeah. Now it's like this point as we move down. Imagine this point's moved down here, and this point's moved up here. Difficult to find. Difficult to find that. And I think this theorem is used twice. Can be used twice in this problem. But yeah, really hard. So they both start at DB. This one goes to the edge, and this one goes to the center. Look for that. So this is center, edge, both same starting point. It's just they've been moved around a bit. This comes around here, and this has gone around there. Difficult to find. Yes, Nola. Oh yeah. Well, this is double this. So in this theorem, it says that if this one is x, this one is 2x. So there, this one is 130. So this one has to be half this. The angle at the center is half the angle at the edge. Now, it was hard to find, but perhaps if we drew it without the rest of the lines, it might be easier. This one goes to the center. This is a bad circle, I know. This one goes to the center. It's 130. And then this one goes here. It's that. So this one is double that one. Imagine this point moved around here, and then it would look the exact same as this, but upside down. Yeah, tricky to find that one, but yeah, 65. Second part, did anyone get an answer for that? Taran?
115.
Yeah, 115. 115. Taran, how'd you get it?
Because 130 connects to the circle in the center, which is 360 degrees. So you subtract 130 from 360, which gives you 230 on the outside.
Okay, so you get 230 around here. Yeah.
And then you're looking for y, which is d and b.
You're looking for up here, yep.
Half of 230.
It's the same theorem, yeah. It's the same theorem again. This angle is 230, which means this one is half of it. If you shove these points around, if D and B just slid around to these 2 points, it'd be the exact same shape as the original diagram when you drew it for your theorem. Is this not the first theorem?
No, I meant for the second question, I used this theorem from the question before.
Yes, same theorem, that's what we said. It's the same theorem, both. You can,
But I meant like, I used like BCB, and then the theorem were like,
cyclic quadratic. Yep. Yeah, you could do that as well. It might take a little bit longer, but you'll get it there as well. Tricky question for just 2 marks. But yeah, that's about recognizing. If you see a question like this, go through your theorems and try and figure. It's going to be one of them. But it might be just a little bit moved around like this one has. Yeah, Misha.
basically what I did was, you know, the theorem where you it's 2 times.
Mm.
I just kind of did that anyways.
Well, that's what it is. That's the 2 times one.
Yeah.
Yeah, it's the 2 times one twice. I was just stating that if you move these points around, it would look more like the diagram we drew.
Just kind of drew the triangle.
Yeah. Okay. Vectors. So hopefully this was a slightly easier question, a little bit unusually asked. I want to get vector P, but I have to use A and B. B is just 2 to the right, if you want to just talk about it in English. And A is 1 to the right and 2 up. So using those, can you get P? So I think if you go 2 to the right and then go 1 to the right and 2 up, you'll get there. In other words, you got to add B and then A, and you get there. So A plus B or B plus A is fine here. So it's just about what direction does this go overall. Q then, if you go 2 to the right, that's B. And then you go, so I just did this by trial and error. I went one to the right and 2 up. That's A. So that's B plus A. And then if I go 1 to the right and 2 up again, that's B plus 2A. And that gets me from here to here. Yeah.
Can we just write the vectors of each one?
Yeah, you can do that.
Yeah,
Yeah, if you
calculate.
Yeah, you can calculate. Yeah. I'm trying to do visual. Yeah, you could go. Okay, this is 3. What's it? 4 right, 4 up, and then use that. Yeah, definitely. And the last one then, or it's a straight line down. Neither of these actually go down, so you're going to have to do some negatives. I think if you go negative A, and then positive B. 2 negative A's here and here. So 2 negative A's, positive B. Or you can write these all the other way around. 2A plus B and B minus 2A are all okay. Okay. Question 7. Or question 8. All right. If this question came up, I'd hope you get full marks in it in the exam. Q minus P, so Q is 3, 2. Minus P is 2 minus 1. And then just read them as is. 3 take away 2 is 1. 2 minus minus 1 is 3. 2 minus minus 1 is 3. 2 times P is then 2 times both these numbers. Make sure to multiply both. 2 times 2 is 4. And 2 times minus 1 is minus 2. The modulus, the absolute value of 2p. We've already worked out 2p here. It's 4, 2. So to get the absolute value of that, you square 4 and you square minus 2 and you get the square root of that. So if p is going this direction, which it's not, but you're looking for this length here. 4 squared is 16 and 2 squared is 4. Add those together, you get square root 20. Not square root 12. A minus number squared is positive. Yes, Jane?
Is it okay if you put for your answers square root of 20 or 2 and 5?
Someone's been working. You know your surds?
Do we
Do
get?
you want to explain how you get 2 root 5?
I don't know. I just know that in my mind.
You do, yeah. So root 20 is root 4 times root 5.
Yeah.
And root 4 is 2. So it's 2 root 5. I won't mark you down if you write root 20. In the actual exam, if they ask you for surd form, which they haven't asked here, fully simplified, you need to give this. They haven't asked for anything fully simplified, so root 20 is fine. Yes? You won't have the calculator. It's still in the non-calculator section, this. So you won't have the calculator, so you won't be able to do that. Yeah, so it's fine for now because you probably missed the fact there was a non-calculator one. But yeah, in general, you won't have it. So just leave it as root 20. Yeah.
If it's a non-calculator section, what's stopping you from just using the
person who didn't listen at the start. The test is going to be in two parts. One with the calculator, one without. You're going to hand up the first part and then start the second part with the calculator.
Start the second part next week.
No, it's same day, two parts. Okay. There you go. That's how I'll stop here. All right. Right. Okay. So A and B are points. You can plot them out if you want to do that. That might be a good idea if you're not entirely sure. 0, 2 is here somewhere. 0 and X, 2 and Y. 2, 7's up here somewhere. That's 2, 7. 0, 2. How do you get from A to B? This is A, this is B. I need to go 2 to the right and 5 up. 2 to the right, 5 up. Yeah.
A to B is the same as B to A.
It's the same as B back to A.
No, B minus A.
Somebody's been working with the tutor.
Sorry?
Somebody's been working with the tutor.
Could I just
Yeah, you can do that. Yeah.
the vector 2, 7 minus O2?
Yeah, you can. Yeah. I think that just drawing it might be easier, but yeah, you definitely can.
But that would work.
Yeah. You're just trying to find what's the difference between 2 and 7 and 0 and 2 doing that method.
I wouldn't have to draw that actually.
No, you wouldn't have to draw. No. You could write them as column vectors and then subtract. But I think that overcomplicates things a little bit. But more than welcome to do it, definitely. Find the coordinates of C. So C is some point that's not here. But it is twice the jump we just did. Twice this. So twice this. 2, 5. That's a jump of 4, 10. 4 to the right, 10 up from this point. So 4 to the right from 2, 7 is going to be 6, and 7 up from 10 up from 7 is going to be 17. Now there is a vectors method of doing that, but I think it's much easier. Visualize. Yeah.
I think the vector method is easier because you can pretty much just write 4, 10 equals x minus 2, y minus 7, and then you have to find x's value to make it 6, and then y's value to make it.
Depends on what your strengths are in maths. If algebra is a strength, yeah. If algebra is not a strength, putting in x's and y's is going to be difficult. So I'm going to use this method as an explanation, but you can use the column method where you solve algebraically, yes. But I think it's a bit difficult. Okay, so we're just using the jumps right and up. Okay, 670. All right, the last non-calculator question. Wasn't too bad, hopefully. You're looking, straight away I see this alternate angle. I know you're looking for angle ACB, but I can't get that straight away because I don't know this over here. So I see this alternate angle, which means that is 42 degrees. And this is an isosceles triangle, which means 180, take away 42, gives me 130 something. And then divided by 2, because it's split between these two isosceles, and I get 69. Okay, question 1 of the calculator allowed section. I don't think the calculator helps that much for some of these. Okay. Complete the statement. The angle OAP is 90 degrees. So OAP, this angle here, this entire angle here is 90 degrees because, anyone have a reason? Ashil?
It's tangent,
Yeah.
and it goes to the radius. So,
Yeah. AP is a tangent to the circle. And okay. Or even just saying tangent to the circle. That's what they're looking at. Tangent to the circle. If you said tangent to the circle, you're good.
That's all you have to say.
Yeah, what'd you say? What'd your tutor say?
No, I think this is.
Go on.
I was like, old we can already be gone, but now.
Okay. Let's go on. OAB then. OAB. AOB. AOB. This here. All right. I think if you take out, with this many lines, it's a bit difficult. But if I take out this shape, this kind of kite-like shape, I know that these are two tangents, here and here. So that's 90 degrees. That's 90 degrees on my off screen. Those two are 90. I take out this shape. This is 46. And then I can find that. Because it's quadrilateral. You don't need to. It's just 90, 90. You can split it in half and then work off two bisecting angles, 23 and whatever. If you take away from 360, I think you get 134 here. Could be wrong. So I just made a quadrilateral force. Any four-sided shape has to add to 360. Okay. Okay, so this is going to be tricky because it's on the other page, but I'll keep flicking back. OAB. 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 So this little angle in here. Something that I could suggest is that these two angles are the same because that's two radiuses of a circle. So I got this triangle, two radiuses. These two angles are the same, and I've just found this to be 134. Which means these two must add to what's remaining divided by 2. So what's remaining? 46 between these two. Divided by 2, because it's isosceles, 23. Next angle, ACB. ACB. This one. All right, so we're back to theorem 1. If I have A and B here, and they go to the center, and they also go to the edge, which they do, so A and B goes to the center, this angle is going to be double that angle. This angle we found, it's 134. This one then, it's going to be half that. What's half 134? 67. 67. Angle ADB. ADB. Now this is also you can also use theorem 1. Double the angle. This is going to be half this angle. If I draw that separately, A and B again, something goes to the center, creates this angle, and also goes to the edge, creates this angle. Those two angles have that relationship. Yes, sir.
How we just divide multiply 46 by 2?
There's multiple ways I said, yeah. So 46 by 2. I'm not sure you can do that.
Yeah, but it's still the theorem.
46, as in this?
Yeah.
That's not inside the circle.
Oh, yeah.
It's to touch the edge. Okay, so we have to find this one on the outside. So I think we know the inside is 134. On the outside then is 360. Take away that. That's 226. So this one is 226. This one is 226. Which means this one's half that. That's 113. So maybe an idea, if you're absolutely stumped in the exam and you see a shape like this or any shape like that, and you can't figure out what the angle you're looking at, double or half one that's already there, because you don't need to explain. So that might be an idea. Double or half. So you can figure out whether it looks like double or half one that's already there, and just put it down. You don't need to explain. All right. Next one. OB bisects ABC. So OB bisects ABC. O to B. This line bisects ABC. So these two angles are the same. That's what it's saying. Cuts it in two. Bisect. Cuts it perfectly in two. We've already found this one out earlier on. Forget what it is. Was it 23? So that's 23. And that one's 23. So the whole thing's 46. Right. Now what we need to find? Find OAC. OAC. This one up here. I think the easiest way is to just look at it as a quadrilateral. four-sided shape. I think we have this kind of weird quadrilateral shape, but it's four sides. There's 2, 2, 6 here. I've just found that that's 23. This I found earlier on to be something. So, thank you, 67. And then this one I can find. If I just add them up and take them away from 360, I'll find the one on top. So I found a quadrilateral, must add to 360, and that's something. What was it? 39, I think. Is it 24? Oh. It could be. I'll do it. 360. So you 226, 226, 67, 23. 67, 23, that's 90 anyway. 90, and this is going to be 316. Oh, yeah, 30, 44. 44, sorry. Oh, there's so many angles going on. You can do it multiple ways. Yeah, absolutely. All right. The area of a triangle like this formula is given on the front. This one, half BC sine A or half AB. So it's a half the area, two sides, and the angle in between. That's what that formula says. A half 23 times 11 times sine 50. So I just put in the two sides and the angle in between. $96.9. The value of x then can be found a few different ways. You can use the cosine rule. It's probably the easiest way. You could go about finding another angle and then use the sine rule, but you don't have to. Let's go straight to cosine. Felicia? No. This is what you're going to get. Tough luck. So the cosine rule is a squared b squared a squared plus, or a squared equals b squared plus c squared minus 2bc cosine a. So that's the same thing. A is the opposite. They must be just opposite each other. A and big A. A and big A. So it's A in this case is actually x. X squared is equal to 11 squared plus 23 squared minus twice 11, 23 cosine 50. So you write it all out. Get your calculator. 11 squares plus 23 squares minus twice times 11 times 23 times cosine 50, close brackets. That gives you an answer. So x squared is 324 point something. I'm going to get the square root of that. Second square root, and the answer. Try not to round too early. So I'm putting in the whole answer here by pressing second answer. And I get around 18. 18.0 or 18. Okay?
So you got square root.
I did square root, yeah. So x is going to be the square root of 324, which is 18. Yeah. You could use sine cos tan ratios. Yeah, definitely. Cosine rule is the quicker way. Did you get the same answer? I didn't. Problem is you don't know. You can't half 23. When you do this line, you know this is 11 and this is 50. You don't know that this is 11 and a half because that's not halfway. This is a 90-degree angle, so you can find this much, you can find this much, but then you need to bring that over to this side because 23 minus this, and then you have this side, and it'd be Pythagoras then. It would take too long. But you'd end up using cosine rule and then Pythagoras, which is this. Look, this is Pythagoras, cosine rule by ratio. Anyway, moving along. Question 3. Find an expression in terms of x for the area of the triangle. So it's the same formula. Or similar. Half of x times x plus 2, either side of the angle, sine 60. Now, give your answer in third form. Means if you worked out sine 60 to be a decimal, you will get it wrong, unfortunately. We need third form, which means, oh, no battery, great. We need third form, which means we go back to the table we created at the start of the exam on page 1. Sine 60 is root 3 over 2. So if you see third form, you have to refer back to this table. Yes, Chief.
Is there a way on the calculator to find the third form?
There is, okay. Look. So that's a half times x plus 2 times root 3 over 2. Give your answer. So simplify it as much as possible. X times x plus 2 is going to be x squared plus 2x. And maybe you could say that's half of root 3, so that's root 3 over 4. I'd be happy if you just left it with that. So I just multiplied the x's together and this together, the n2 together, and I left it at that. I think if you gave that answer, you'd be fine. It didn't say to fully simplify. So you didn't need to multiply out. What did your tutor say, Jane? All right, so the area of the triangle is, so now they say it is, show that. Okay, so this is this. So root 3 over 4, x squared plus 2x is 18 root 3. Show that. So you got to manipulate this, show your algebra skills, be able to manipulate this down to what's written on the left. Now, both sides are multiplied by root 3. So I can divide both sides by root 3, and I end up with just x squared plus 2x. Still divided by 4, but the root 3 is gone. It's equal to 18. I've divided both sides by root 3. Okay. If I multiply both sides by 4, I get x squared plus 2x is equal to 18 times 4, which is 72. And then if I subtract 72 from both sides, I get that. So I multiply by 4 here. Okay. Anyone get that?
I did.
Sweet. Anybody else? No? Rafa? Nice. Tricky. That was difficult. All right. All right, so we have to draw a line here. The perpendicular from E to AB is not written or not drawn, so it's this line, isn't it? We make a right angle perpendicular on the diagram. Find the length of that perpendicular, so let's call it x. I can use sine, cos, tan here because I've got a right angle triangle. I think I got the opposite to 70 and the hypotenuse. So opposite and hypotenuse telling me sine of 70. The angle is x over 13. Rearrangement of that, 13 times sine 70 is equal to x.
You get a 10 marks in this test?
Yeah. So you get 12.2. I have a little check to make sure my answer makes sense in the context of a right angle triangle. I think it does. That's quite a long side compared to that, but not quite as long as 13. Yes, Jack? Yeah. Okay. Questions. Last question, is it? Sweet. Length BD. B to D. I see another right angle triangle. And I also see that this is marked the same as this. Oops. right angle triangle. This is marked the same as this, so this has to be the same length, 13 centimeters. And I'm looking for this length. Let's call it y. Call it whatever you want. Okay, so I only have one angle here, 50. Y is opposite it. 13 is alongside it, adjacent. So I have opposite and adjacent. That's going to tell me tan. Tan of 50 degrees is the opposite side divided by the adjacent side. Opposite was y, adjacent was 13. Solve this, I get 13 times tan 50 equals y. Hopefully all your calculators are already in degrees and not in radians. And you just type this in. 15.5, the three significant figures. 15.5. Okay, so I know that's 15.5 on my diagram. 50.5. I did find x as well to be 12.2. Just put it in just to see. And I know the last question is probably going to be harder, or last two. CD. CD next. C to D, this one. Here to here. Okay. So I have a new triangle. I can use this new triangle maybe. I have two sides. Oh, I want to find the third side. Can I just use Pythagoras? No. Why not? Not a right angle. Okay. That's ruled out. Let's call this side A. Okay. I could use the cosine rule if I knew this angle, because it's opposite. Can I find it? Yes. Because this is 70 from over here. This is 90. Marked. So 70 and 90, I think we left with 20 degrees for that angle. So now I use cosine rule. Three sides, one angle. I should point to cosine rule. So let's do it. That a squared is equal to the other two sides squared. Let's write them 15.5 and 15. Doesn't matter which you call A and B, or B and C. Either is fine. 2 times 15.5, 15 cosine of the angle, which we just found to be 20. Type all that in, and hopefully you'll get 28.29. A squared is 28.29. And I'm just going to get the square root of that. 5.32. Rounded, three significant figures. Just going to have a little check, make sure that makes sense. 5.32 for this length. Yeah, I think that's okay. It's definitely a lot shorter than the other two. And it's not to scale, but it has to still make a bit of sense. And the last question. Taryn, good? Okay. Area of quadrilateral ACDE. 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 Oh, it's the whole thing. There's a few ways you can do this. Split it up into 3 triangles that are already there is probably the easiest thing to do. There's 3 triangles there. 2 of them are right angle triangles, or not right angle triangles. One of them is right angle triangle, and 2 of them are not right angle triangles. It's easier to get right angle triangle because with a right angle triangle, you know the perpendicular height, and you just go half the base times the perpendicular height. We actually know the perpendicular height of the isosceles as well. Do we know the base? No, we don't. So that's why maybe we just use our formula from the front. So we have a half AB sine C, and we're going to use that twice. Let's label them triangle 1, 2, 3. I'm doing these. big triangle 1 and 3, we got to use that. And for triangle 2, we'll just use half the base times the height. Okay, so triangle 1. Do we have to find? We think we have to find this side, do we? Maybe I'll come back to that. We just get triangle 3 done first. 3, half the base times the height is half, or half AB sine C is half, 15.5, 15 sine 20. That'll give me that area. Around 39.7598. Okay. The right angle triangle, that's area 2. It's going to be just half 15 times 13, because I know that's the perpendicular height. Half base times height, perpendicular height, which is a half 15 times, I've already forgotten, 13. Okay. 97.5, whatever units it is. And now for number 1. Let's have a little look at it again. Can we do? That's 70. 2 70s. Then we know this, don't we? Okay, we do know the top. What's this entire angle here? Is 70 plus 70, take away 180, so it's 40 degrees up here. So I can use 2 13s either side of the 40 degrees. So it's the same one, half AB sine C, which is a half 2 lengths of 13 either side of the angle 40. Okay, add that to 97.5, add that to 39.7598. Which you're not seeing on screen. I got 191.92 to 3 significant figures. Centimeters squared. All right.